When you step out onto a screened-in balcony during a storm, the fiberglass mesh wrapping the space creates a powerful psychological barrier. It feels like a solid wall. But standard insect netting is designed strictly for pest control, and relying on it to catch a falling body creates a dangerous false sense of security. Take a look at this collapsed structure from a recent devastating hurricane. When contractors apply the exact same lightweight framing used on ground-level patios to second-story decks, the results during extreme weather or sudden impacts are catastrophic. A ground-floor patio cage primarily needs to support its own weight and resist moderate wind. An elevated deck structure, however, sits directly in the path of accelerated aerodynamic wind currents and has to physically prevent occupants from plummeting over the edge. True protection at higher elevations requires specific, heavy-duty structural anchoring and precise load-bearing metalwork. It takes an intricate synthesis of specialized engineering to secure a space, rather than just pulling netting tightly across a frame. This technical diagram outlines a critical threshold in the Florida Building Code, the 30-inch rule. If your deck or balcony sits more than 30 inches above the surrounding ground, the state legally mandates the installation of a structural guardrail along the perimeter. That 30-inch metric isn't arbitrary. It is derived directly from human biomechanics. Studies show that a sudden, unimpeded drop of exactly 30 inches onto a compacted surface or concrete pool deck is biologically sufficient to cause severe cranial, spinal, or orthopedic trauma. The moment a deck crosses that height requirement, a simple backyard screen room becomes a heavily regulated life safety device, governed by strict federal and state mandates. This dimensional blueprint illustrates the rigid height mandates for these safety barriers. For a single-family home, the top rail must sit at least 36 inches high. If the property is commercial or multifamily, that requirement jumps to 42 inches to accommodate a wider variety of human traffic. Then there is the 4-inch sphere rule, which dictates the spacing between every vertical picket. This measurement represents the biology of a toddler's head. If a 4-inch object cannot pass through the gap, a child's torso cannot become wedged, eliminating the risk of accidental asphyxiation. Beyond geometry, the barrier has to handle massive kinetic force. The top rail must withstand a concentrated point load of 200 pounds applied in any direction, plus a uniform load of 50 pounds per linear foot. These metrics guarantee the aluminum framework is robust enough to catch a falling adult. Because standard fiberglass insect mesh tears easily under a fraction of that force, it is entirely illegal to use it as fall protection. To meet these safety standards, structural engineers make a sharp distinction between a standard chair rail and a true guardrail. A chair rail is simply a horizontal bar used to brace a frame against wind sway. A guardrail requires up-gauged aluminum extrusions, reinforced corner gussets, and solid load-bearing infill below the top rail. This wind tunnel simulation displays the aerodynamic pressures dictated by ASCE 722 codes. In Florida's coastal hazard zones, a screen enclosure acts as a giant permeable sail. At wind speeds of 170 miles per hour, the structure has to resist windward pressures of up to 66 pounds per square foot. High-density no-seam or pet-resistant mesh keeps tiny insects out, but the tighter weave simultaneously captures significantly more air. This increased porosity transfers higher aerodynamic loads directly into your railing and vertical support columns. Look closely at this severely bent aluminum frame. Some building codes allow for under-engineered frames if the homeowner agrees to manually remove the screens. But forcing someone to dangerously slice out their second-story netting hours before a hurricane makes landfall is highly impractical. Enclosures must feature stay-in-place engineering. Failing to over-engineer the safety barrier for severe aerodynamics creates a sail capable of ripping the host structure apart. For luxury estates and high-rise condominiums, architects often replace vertical aluminum pickets with solid structural glass to preserve panoramic sightlines. However, monolithic tempered glass is strictly prohibited on elevated surfaces because it can spontaneously shatter and rain hazardous shards onto pedestrians below. True structural glass must be built with laminated safety plies. To meet code, these glass panels are engineered to an extreme safety factor of 4, meaning they are mathematically validated to handle an 800-pound theoretical point load before yielding. To operate in the Miami-Dade high-velocity hurricane zone, this glass has to endure brutal testing protocols. That means surviving the impact of a 9-pound wooden timber fired from an air cannon, followed by severe static pressure, and ending with 9,000 continuous cycles of hurricane-force wind pressures buffeting the already shattered glass. Maintaining a luxury aesthetic without obstructing a coastal view requires subjecting the materials to the most punishing structural testing on Earth. Even a guardrail engineered to repel 800-pound impacts and 150-mile-per-hour winds is entirely useless if its base connection to the concrete deck fails. Using standard mechanical wedge anchors on the edge of a balcony causes extreme outward pressure inside the drilled hole, leading to a structural blowout known as edge spalling. This technical photo shows the correct engineering response. Notice the heavy-duty bolts securing the base plate. These utilize chemical epoxy anchor technology. Epoxy binds the hardware deep into the slab with massive pull-out strength, generating zero expansive stress on the concrete edge. Mixing stainless steel hardware and aluminum frames in salt-heavy air triggers a rapid chemical reaction called galvanic corrosion. Over time, this eats away structural integrity. Stopping this chemical reaction requires strict metallurgical isolation. High-end builds separate the dissimilar metals using specialized EPDM rubber gaskets, nylon sleeves, and insulating washers. Ultimately, an aluminum structure designed to outlast a Category 5 hurricane is only as strong as its weakest chemical bond. Look at this aerial photograph of the tragic Surfside collapse. Following this disaster, Florida reclassified guardrails and elevated enclosures as highly regulated infrastructure, aggressively enforcing stringent new state mandates like Senate Bill 4D and mandatory milestone inspections. These unyielding real estate laws mean your enclosure must pass brutal forensic audits. Screen Factory Florida operates precisely for this environment, providing an engineering-first approach that ensures total compliance long before the inspector arrives. This architectural wireframe highlights Screen Factory Florida's structural advantages. Every build incorporates reinforced chemical concrete anchorage, structural K-braces for severe wind load, and a dedicated in-house permitting team to navigate the complex local paperwork for you. Don't wait for a failed inspection or a storm to reveal your home's weak points. Contact Screen Factory Florida today for a free measurement and a tailored 3D design to ensure your elevated enclosure is fully code compliant. Proper engineering protects the property's financial value and ensures the structure remains an effective life safety barrier for the family living inside it.